Where does oil come from?
Many people imagine that oil just sits underground in a huge cavern and don't really realize the very remarkable geological conditions that are responsible for it. Briefly, oil is derived from algal growths, excessive algal growths that occasionally occurred in the geological record at times of extreme global warming. Basically what happened is you had this extreme heat from the climate. The algal growths proliferated in lakes and seas and in special geotectonic settings, really, and they effectively poisoned the seas such that no life could continue. The thing was devoid of oxygen. And the organic remains of all of this stuff, the algae themselves and the marine life that had died, fell to the seabed, and normally it would have been oxidized in the process of falling or consumed by bottom-living organisms, but in this special condition it was preserved. And then other sediments were washed in from the rivers surrounding the seas and buried the organic material, and these troughs in which occurred subsided gradually, and more sediment filled them up, so that eventually the organic material was buried to a depth of about 2,000 meters or so, at which point the temperature had risen sufficiently for a chemical reaction to take place that converted the organic material into oil and gas. And this chemical reaction caused the volume to expand. It was as a result of the chemical reaction, the volume expanded. That meant that the oil was under immense pressure once it was formed on its birth. Under this enormous pressure, it fractured the rocks above it and gradually moved upwards. And now in some cases it may have just moved upwards and disseminated and was lost, and it was just a disseminated deposit of no use to anybody. But if it encountered in the course of its movement upwards a porous formation such as a sandstone made up of grains of sand and pore space between the grains, then the oil would move along this conduit, so to speak. Now, if this conduit just rose straight to the surface, well, the oil would simply flow upwards and escape at the surface, and these huge, heavy oil deposits of eastern Venezuela and western Canada, in fact, are examples of just that, where the oil just flowed up to the surface and it was weathered and attacked by bacteria and so on, leaving behind this heavy, tarry material. But if, in between where it was formed, in the depths of the basin and the margin, the rocks had been folded or cut by faults, these created traps, and the oil just accumulated in the highest part of this conduit through which it flowed. So you have structures called anticlines, geological structures, which could be compared with an arch, and the oil accumulates at the top of it. Now, oil generally contains some gas, and so the gas, under different conditions of temperature and pressure, separates out. So very often you have a little gas cap above the oil leg, and beneath the oil you have water that filled the pore space in the rocks left over from when it was deposited. So that's, in simple terms, what an oil field is. Now, where the oil source rocks are depressed further, much deeper, into much higher temperatures, then the oil is broken down into gas. So people sometimes say, well, you know, we could drill deeper to get more oil, but you can't, because at a greater depth it's already gone to gas. And gas behaves very differently simply because it is a gas, and we perhaps talk about that later. So that's the essence of where oil is. Now, producing oil, you drill a well down to tap into this sand, and it's 6-inch diameter steel pipe is put into this thing, and then you have to let off explosive charges in it to make holes to communicate the formation with the well bore, and then the pressure differential, because the oil in the reservoir is under high pressure with the weight of the overlying sediment sitting on top of it and the column of water that's pressing it from the side, so to speak. And so there's a high pressure in the formation and a low pressure in the well, and so the oil flows in and flows to the surface. But as you produce it, then of course the water gradually rises underneath it, and you have to go back to the well and seal off where the water would otherwise be invading, and sometimes the gas cap comes down and you've got to seal it off. And so there's a lot of work goes on all the time. Then another important point to remember is that initially the well is able to drain the rocks immediately around it within a radius of a few feet or a few hundred feet. And as you produce it, it then has to draw on oil ever further away. And this oil that has to move through these tortuous paths between the grains of sand, of course, these form constrictions. And so gradually the production rate falls as it's got to tap ever more difficult oil ever further from the wells. Well, of course, then you can drill another well at a certain point, do infill drilling around to reduce the spaces between the wells. And so that means drilling more wells. And when you first find it, of course, production starts, and if you're onshore in Texas, well, you can immediately hook up the first well, and then you drill the next one, and production rises, and at a certain point you usually reach a plateau of some kind, which is a deliberate plateau, and it's convenient to produce at a certain level steadily, and you build the pipelines and facilities to match that level. But then gradually, as the wells have to reach these deposits further and further from the well bore, production rate begins to fall, and inevitably the production of the field begins to decline, eventually to exhaustion. So you have this sort of bell-shaped curve that is characteristic of every single oil field. In the case of an individual field, it isn't a regular bell, it's usually skewed to the left because flush production starts at a high rate and gradually declines. So when you found your first well, you have this inevitable pattern of starting production, rising production, peak, decline to exhaustion. I mean, this is very obvious, really. And then, of course, you can look for another field. That brings us into the realm of discovery, and if you're in an oil province, you very likely can find another field down the road in another anticline fed by the same eternal source rock. But going back to Pennsylvania, already by the turn of the century, they had already found all the structures that could produce, and that little old province was already in decline by the turn of the end of the 19th century. Now, in a museum in Titusville, Pennsylvania, there is still an old well producing 2 or 3 pints a day. So, this question of running out doesn't happen for an awful long time, but there's a huge difference between 30,000 barrels a day and a few pints in a museum.